3, 2, 1.
This is the record-breaking reaction. It is more than 150 million degrees centigrade.
Japan has always been a land of brilliant ideas and creative solutions.
That we can create a mini sun, the right kind of mini sun, hold it there for a sustained period and get really good performance levels.
The country has amazed the world with its incredible achievements and contributions.
Creating mini-stars inside reactors like this is one of the greatest technological challenges humanity has ever faced.
However, Japan has also faced significant threats and challenges from neighboring countries and rivals.
An atomic bomb called Little Boy was dropped on Hiroshima by the United States.
Recently, Japan has admitted they created something so powerful, it's become terrifying.
It's not turning down.
What is this massive thing that is so scary, and how might it impact the future of Japan and its surrounding areas? Join us as we uncover the powerful thing Japan has created that has become so terrifying. Japan's journey through the nuclear age. To understand Japan today, especially in terms of nuclear weapons and international relations, we need to go back to 1945, the year that changed everything. World War II was nearing its end. Germany surrendered in May, and by July, the Allies had developed two powerful nuclear bombs as part of the Manhattan Project: Fat Man, a plutonium bomb, and Little Boy, a uranium bomb. On August 6, 1945, Little Boy was dropped on Hiroshima. Despite the devastation, Japan's Prime Minister Suzuki insisted on continuing the fight. Just 3 days later, on August 9, Fat Man was dropped on Nagasaki. The effects were catastrophic. Within the next 4 months, between 90,000 and 100 to 46,000 people died in Hiroshima, and another 39,000 to 80,000 in Nagasaki, many from burns, radiation sickness, and injuries. Finally, on August 15, Japan surrendered to the Allies, marking the end of World War II. This marked the beginning of the nuclear age, with the US developing more atomic bombs by 1946. The Japanese experienced firsthand the almost incomprehensible power of nuclear weapons. However, understanding Japan means looking at its journey before and after this pivotal moment. By the end of the 19th century, Japan was modernizing rapidly, keeping pace with Europe's Industrial Revolution. But as it grew stronger, it also adopted the imperialistic tendencies of the Western powers, launching a war to control much of East Asia and Oceania, which led to immense suffering and about 30 million deaths during the Pacific theater of World War II. The war's end brought severe destruction to Japan, leading to a period of rehabilitation and reform led by the United States. In 1947, Japan adopted a new constitution, renouncing war and committing to peace. This no-war constitution declared that Japan would not maintain land, sea, or air forces, emphasizing a universal commitment to political morality and peace. Despite the devastation, Japan recovered and flourished in the latter half of the 20th century, largely through its partnership with the United States. Yet the impact of the atomic bombings lingered, affecting survivors' lives for decades. Over the past 70 years, Japan has relied on its Treaty of Cooperation and Security with the United States. This agreement means the U.S. will defend Japan in case of an enemy invasion. Following recent global tensions, like Russia's invasion of Ukraine and China's military exercises near Taiwan, Japan's defense strategies have become more crucial. For instance, in 2022, China launched ballistic missiles that landed within Japan's exclusive economic zone, highlighting regional threats. North Korea also poses a threat, having fired multiple missiles in recent years, prompting emergency alerts in Japan and military responses from Japan, South Korea, and the United States. These events underline the fragile and tense situation in East Asia, where nuclear capabilities remain a significant concern. Despite these challenges, Japan's no-war constitution remains central to its identity. The country's defense spending has traditionally been capped at 1% of its GDP since 1976 to avoid becoming a military superpower. However, recent global tensions have led to increased defense budgets, breaking this precedent. In 2022, Japan announced a new security strategy in response to the increasingly volatile global climate. This strategy includes investing in new defense technologies and enhancing missile capabilities, emphasizing preparedness for prolonged crises. Prime Minister Fumio Kishida has ensured these measures are defensive, not preemptive, with strong support from the United States. While Japan's new defense strategy has sparked controversy, especially with North Korea and China, it signals a significant shift. Japan is stepping up as a powerful ally, determined to protect its sovereignty and contribute to regional stability. This evolution from a pacifist nation to an assertive player on the global stage is closely watched by the world, as Japan balances its historical commitment to peace with the demands of contemporary security challenges. JT-60SA's Fusion Frontier. The JT-60SA is a high-tech machine that uses the newest plasma control technologies to ensure everything works perfectly. It has advanced heating and current driving systems to maintain the plasma in the right conditions. These systems work together with control tools like magnetic coils and extra heaters to make tiny adjustments to the shape and stability of the plasma. This precise control is essential to avoid problems and keep the plasma stable, which is crucial for generating fusion energy. But there's more to this story. One of the most exciting aspects of the JT-60SA is its role in long-term research. This tokamak is not just focused on solving today's issues, but is also preparing the ground for future innovations in fusion technology. The JT-60SA project is at the forefront of a global effort to harness fusion energy, the same power that fuels the sun. Located in Japan, this facility is more than just a reactor. It's a testbed for the future of energy. Its main goal is to experiment with different ways to control plasma, the hot, charged gas needed for fusion. By doing this, JT-60SA aims to make reactors more efficient and reliable, which is crucial for powering our world. The experiments here are vital because they help scientists understand how to keep plasma stable inside a reactor, a key part of making fusion energy work. Moreover, the JT-60SA project is essential because it doesn't just advance its research. It significantly contributes to international efforts in fusion energy. The discoveries made here are shared with the ITER project, helping to solve challenges and improve processes. This collaboration speeds up the progress of fusion science and brings us closer to using fusion power in everyday life. By perfecting these technologies, JT-60SA is laying the foundation for a future with cleaner, sustainable energy sources. The JT-60SA project is making significant strides in nuclear fusion research, continuously updating its studies to align with discoveries at ITER. Initially intended to support ITER, JT-60SA is now focusing more on what future fusion reactors will need. The project's goals are expanding to include better steady-state operations and exploring new plasma scenarios, which are the conditions expected in future fusion power plants like DEMO. Additionally, it's about international cooperation, especially between Europe and Japan. This teamwork is crucial not only to tackle the technical and logistical challenges of such a complex project, but also to build a strong community of skilled researchers and engineers. This growing community is essential for maintaining and expanding the knowledge needed for future fusion projects. JT-60SA is not just any research center, it's a beacon of hope for future energy solutions. This facility uses the latest in superconducting magnet technology and advanced plasma control systems, setting new standards for future energy projects. It shows the amazing potential of fusion energy as a sustainable and endless power source. But there's more to this story. As JT-60SA progresses, it will greatly improve our understanding of plasma physics, bringing fusion energy closer to becoming a practical reality. This progress marks a significant step towards a revolutionary way of generating power that could change our world forever. Japan's groundbreaking fusion reactor, JT-60SA, uses a series of powerful magnets to contain a super hot gas called plasma in a donut-shaped chamber. This extraordinary piece of technology, the largest and most advanced of its kind, plays a crucial role in the International Thermonuclear Experimental Reactor. It helps scientists understand the complex science behind fusion energy. On October 26, 2023, after nearly 15 years of careful development and testing, JT-60SA achieved a major milestone by producing its first plasma. This significant achievement showed the world that the reactor was working as planned. Sam Davis, the project manager at Fusion for Energy, happily confirmed that everything is operating perfectly. Fusion for Energy, a European Union organization, works closely with Japan's National Institutes for Quantum Science and Technology to monitor and study the reactor's progress. JT-60SA's success is a major step forward in the quest for clean and limitless energy. The main action in the JT-60SA reactor is nuclear fusion. This is when two tiny atomic cores come together to form a larger one, releasing a huge amount of energy. Fusion happens in a special state of matter known as plasma, which is extremely hot and filled with charged particles. If scientists can control this process well, it could lead to a nearly endless source of energy, similar to how the sun generates power. However, controlling this reaction isn't easy. Even though scientists have had some success with creating plasma, managing and maintaining this powerful reaction is still a big challenge. There's still a lot of work to be done, but the progress made so far is a major achievement. Plasma is different from solids, liquids, and gases. It consists of freely moving electrons and positively charged ions. This mix of particles is what fuels the sun and other stars. In the core of the sun, atomic cores collide with each other at extremely high temperatures, about 10 million degrees Celsius. These high temperatures provide enough energy to overcome the electrical repulsion between the cores, allowing them to fuse. The fusion occurs because, at such close distances, the attractive force between the cores is stronger than the repulsive force. For fusion to happen, the cores need to be packed closely together to increase the chances of collisions. The sun achieves this naturally due to its immense pressure and gravity. Scientists are fascinated by fusion energy because it has the potential to provide a nearly limitless power source. This interest began in 1925, when British scientist Arthur Eddington proposed that stars, including the sun, get their energy from nuclear fusion, where hydrogen cores combine to form helium. Since then, scientists have been eager to replicate this process to produce large amounts of energy. Starting in the 1950s, the idea of fusion energy gained attention because it would produce much less radioactive waste compared to traditional nuclear reactors that use fission, which involves splitting uranium atoms. Despite the promise of fusion energy, the challenges of making it practical are still significant. The pursuit of practical fusion energy. Just 1 gram of hydrogen isotopes used for fusion could give off as much energy as nearly 10 tons of coal. Ever since scientists figured out how nuclear fusion works, they've been striving to make it a reality. Fusion, if we can make it work well, could give us an endless, safe, and clean source of energy, potentially fulfilling the world's energy needs. However, creating fusion energy on a large scale is still a major challenge. Making fusion work on Earth is tough, but it could be game-changing. Fusion could produce 4 times more energy per kilogram than the nuclear fission used in today's power plants. This big difference drives scientists around the globe to push hard to turn fusion from an idea into a practical energy source. But we're still a long way from solving all the problems. Imagine a power source that's about 4 million times more efficient than burning fossil fuels like coal or oil. Most current fusion reactors use a mix of tritium and deuterium, which are types of hydrogen atoms with extra neutrons. Just a few grams of these materials could theoretically provide enough energy to power a whole country for 6 years. Not only is fusion fuel incredibly powerful, but it's also quite easy to get. Tritium can be produced by fusing neutrons with lithium, which is naturally available on Earth. Deuterium can be collected from seawater, which means we won't run out of these resources for millions of years. Plus, unlike traditional nuclear power, fusion doesn't produce long-lasting radioactive waste that could harm our environment and health. What's even more impressive is that future fusion reactors are being designed to be very safe. They operate under such controlled conditions that if something goes wrong, the fusion reaction would simply stop. The plasma needed for the reaction would naturally disperse, ensuring that fusion power could be a major leap forward in our quest for clean, sustainable, and safe energy. Fusion uses its energy up very quickly, so it doesn't risk causing long-term damage to the reactor. This rapid energy use means there's no danger of an uncontrolled reaction or a major meltdown. While both fusion and fission are environmentally friendly because they don't release greenhouse gases, getting fusion to work is extremely difficult. However, it holds promise as a reliable source of low-carbon electricity in the future. The sun achieves fusion naturally because of its immense gravity, but doing this on Earth is much harder. To start fusion with deuterium and tritium, temperatures need to exceed 100 million degrees Celsius. It's not just about reaching high temperatures. Managing magnetic forces and maintaining the right pressure are also crucial. These conditions need to be carefully controlled to keep the plasma stable and the reaction going long enough to produce more energy than it took to start it. Current experiments are nearing the necessary conditions for a fusion reactor, but there are still major challenges like improving energy confinement and plasma stability that need to be overcome to make fusion practical. The toughest part isn't just reaching these extreme conditions, but maintaining them, which is both tricky and costly. Scientists are working hard to find solutions, but it will take time and further research. Nonetheless, the potential of nuclear fusion is immense, offering a nearly endless and clean energy source for the future. The global quest for fusion energy. To create energy through nuclear fusion, scientists and engineers from all over the world are putting in a lot of effort. They are testing new materials and designing advanced systems. Over 50 countries are working together on research in nuclear fusion and plasma physics, and they are making notable progress. Recently, scientists managed to get more energy out of a fusion experiment than they put in, which is a major achievement. This success came from new designs of fusion devices like tokamaks and stellarators, as well as from improvements in fuels, lasers, and other techniques. The success of fusion energy depends on how fast we can develop and approve new fusion technologies. It also relies on how well we can gather resources through global teamwork. Building a strong nuclear infrastructure, including clear standards and best practices, is also crucial for this new energy source. One major fusion project is the JT60SA reactor in Japan. This reactor is designed to heat plasma to 200 million degrees Celsius and maintain that temperature for about 100 seconds. This allows scientists to study and improve how plasma performs and stays stable, which is essential for making fusion power work efficiently. The JT60SA supports ITER, a massive international fusion reactor being built in France. ITER aims to prove that fusion energy can produce more power than it consumes, using the techniques tested by JT60SA. Japan was allowed to build JT60SA and 2 other smaller fusion facilities in exchange for France hosting ITER. This agreement was part of a larger 2017 deal between the EU and Japan, which also included updating Japan's older JT6 reactor from the 1980s. This global collaboration demonstrates a shared commitment to transforming energy production through fusion and sets the stage for a major shift in how we generate power in the future. The JT60SA reactor has a major drawback. It only uses hydrogen and its variant deuterium, but not tritium. This limits its effectiveness and flexibility in some fusion reactions. It shows the difficult decisions and trade-offs involved in developing advanced technologies. Tritium is a special form of hydrogen. It is stronger, more costly, rarer, and more radioactive compared to regular hydrogen. Tritium plays an important role in fusion energy, a promising new technology that could change how we produce power. The International Thermonuclear Experimental Reactor, ITER, plans to use tritium by 2035 to create this groundbreaking energy source. And Japan has set an ambitious goal to become a leader in fusion energy. It aims to build a working fusion power plant known as DEMO by 2050. This plant will move beyond experimental setups like JT60SA and ITER to actual commercial fusion power production. DEMO's main goal is to prove that fusion can reliably produce more energy than it uses, marking a significant step towards sustainable energy. DEMO is expected to be one of the first fusion power plants of its kind. It will face major challenges, such as keeping a stable fusion plasma for long periods and managing the fuel cycle, especially with tritium, which is crucial for fusion. These are key obstacles to overcome in showing that fusion energy can be a viable, large-scale solution. The JT60SA reactor is central to Japan's fusion research. Although smaller than ITER, it is similar in design and plays an important role in developing the necessary technologies for DEMO. Despite facing delays from natural disasters and technical issues, JT60SA remains a key player in Japan's fusion efforts. Looking beyond just experimental reactors, Japan is advancing its efforts through the Fusion Energy Innovation Strategy. This initiative aims to strengthen Japan's involvement in international projects like ITER and to build the expertise needed to develop and potentially export commercial fusion reactors in the future. Japan is working hard to build strong connections with other countries, especially in Europe, through partnerships like the Broader Approach. This effort helps Japan share technology, exchange knowledge, and train new experts in fusion energy. These experts, along with the necessary materials and technologies, are crucial for developing future fusion reactors. Japan is not only focusing on scientific research, but also on the industrial development needed to lead in energy technology. This ambitious plan shows Japan's commitment to becoming a top player in the future energy field and its determination to tackle the major technological challenges involved in making fusion energy a revolutionary power source. The exciting part is that Shai, a key figure in fusion energy, is very excited about these advancements. Recently, there has been a rise in new ideas and investments in fusion energy, thanks to private companies stepping in. Shai is thrilled that more people are getting involved, seeing this growing interest as a sign that fusion energy has the potential to change how we produce power, making it cleaner and more sustainable for everyone. Now it's time for today's subscriber pick. Japan has just admitted they created something so powerful it's become terrifying. In the year 2023, Japan revealed Hoshi no Kage, Shadow of the Star, a new weapon meant to ensure world peace. This device used dark matter to create an unbreakable energy field capable of destroying any threat. Initially praised as a wonder, its true nature soon became clear. One stormy night, Hoshi no Kage broke down. Instead of a protective shield, it released a huge shadow that covered entire cities, leaving only eerie silence and dark ruins. The once respected weapon had become a nightmare, with the shadow growing uncontrollably, swallowing light and life. Fear spread as scientists and leaders worldwide hurried to stop the horror. The shadow's arms reached across oceans, threatening to take over the entire planet. Amid the chaos, a lone Japanese physicist, Dr. Aiko Tanaka, found a way to reverse the effect. She went on a dangerous journey to Hoshi no Kage's core, racing against time and the creeping darkness. With bravery and sacrifice, Dr. Tanaka managed to turn off the device, stopping the shadow's spread. What do you think of the Hoshi no Kage incident? Let us know your answer in the comments section. Japan Massive Weapons. Japan's Ministry of Defense, also known as MMOD, has unveiled its plans to heavily invest in research and development for advanced equipment over the coming years. These plans were detailed in their recent defense budget request. For fiscal year 2024, the budget is approximately 5.48 trillion yen. This represents a 2.6% increase from the previous year. One exciting project is the development of a large advanced robot boat named the Combat Support Multipurpose USV. This boat is designed to perform a variety of tasks to support other vessels. It can engage enemy ships and submarines and also monitor and patrol areas. The robot boat is expected to be about 30 meters long and weigh around 200 tons. This high-tech robot boat, known as a USV, is like a futuristic superhero on the water. It can operate independently or be controlled from land using satellites. Even in challenging weather conditions or unexpected situations, it is designed to handle them with ease. It does not work alone. It teams up with other robot boats to form an amazing crew. This unmanned surface vehicle, USV, isn't just a one-trick pony. It uses advanced technology like artificial intelligence and machine learning to make smart decisions. It can adapt to different tasks by switching its equipment. Depending on the situation, it can be equipped with sensors, missiles, and torpedoes to handle threats. If things get tough, it can dive underwater, making it both a surface and underwater defender. Plus, it's eco-friendly, powered by electricity and sophisticated fuel cells, which helps it stay quiet and efficient. From 2024 to 27, there will be in-depth research on this USV, and the exciting testing phase will take place from 26 to 2030. The goal is to enhance Japan's naval capabilities with this high-tech robot boat, making their maritime forces even stronger in the future. Japan is working hard to stay strong and prepared, especially with China and North Korea making waves. To keep up, Japan has introduced a new and impressive tool, a special robot boat, which we'll call the Unmanned Amphibious Vehicle, UAV. This advanced robot is like Japan's secret weapon, designed to help maintain its strength and readiness. The UAV is a high-tech version of a vehicle called the Assault Amphibious Vehicle, AAV, made by Mitsubishi Heavy Industries. The AAV is known for its toughness and ability to travel both on land and in water while carrying troops and equipment. The UAV looks similar to the AAV but comes with some cool upgrades. It doesn't need a person on board and is packed with advanced features. What's exciting is that the UAV can operate on its own or be controlled remotely from land using satellites. It's incredibly smart, using computer technology like artificial intelligence and machine learning to make decisions and handle different situations. It works alongside other robots and vehicles, forming a team to accomplish various tasks. The UAV, unmanned aerial vehicle, is designed to adapt to different tasks by changing its equipment. It can be fitted with sensors, missiles, and torpedoes to handle threats. But it's not only about combat. The UAV can also transport supplies to troops after they land, helping to ensure everything runs smoothly with fewer personnel. This makes it a very useful machine. Creating this UAV is quite an achievement, especially because it needs to navigate the rough terrain around Japan's islands. To address this, they are adding electric power assistance to make the interior space more efficient and the overall design more compact. They are also using innovative features from another advanced vehicle. The exciting part is that they will start testing these new technologies from 2024 to 2026, with further testing continuing until 2030. The goal is for the UAV to enhance Japan's defense capabilities, especially given the current threats from China and North Korea. Another advanced weapon introduced is the Type 12 anti-torpedo torpedo. This highly sophisticated weapon, used by Japan's Maritime Self-Defense Force since 2012, is designed to counter submarine threats. It can be launched from various platforms, including destroyers, helicopters, and patrol aircraft, making it a versatile and powerful tool in naval defense. This torpedo can travel over 50 kilometers at incredible speeds, making it one of the top torpedoes globally. But Japan isn't stopping there. They're aiming to make it even better. They realize that future challenges could involve even more advanced enemy torpedoes. These enemy torpedoes might be so clever that Japan's current methods to stop them might not be enough. Japan plans to enhance the Type 12 torpedo. They want to give it a new power to deal with these advanced enemy torpedoes. Think of it like adding a superhero ability called hard kill capability. This means the Type 12 will be able to directly strike and destroy enemy torpedoes before they can reach Japanese ships or aircraft. To achieve this, Japan isn't just improving the torpedo itself, but also upgrading the radar systems on their ships. This combined effort will help keep their vessels safe from submarine attacks. Radar is like a superhero's keen vision, detecting enemy torpedoes from far away and guiding them with precision. The new radar upgrade is like giving this superhero even sharper eyes, allowing it to see much farther and clearer. This will help the Type 12 torpedo spot and intercept enemy torpedoes before they get too close. Japan has ambitious plans to complete this enhanced torpedo by 2029. They will test it in various scenarios, such as facing different types of torpedoes and operating at various depths and distances. They hope their improved torpedo will pass all these tests and become a powerful tool against enemy submarines. In addition, Japan has just introduced a new weapon developed in collaboration with the US to counter super-fast and complex weapons known as hypersonic weapons. These include anti-ship ballistic missiles and hypersonic glide vehicles designed to target naval ships. Japan's new weapon, called the Glide Phase Interceptor, GPI, is like a superhero's shield against these threats. Moreover, Japan is working on its advanced system for future destroyers to enhance their ability to detect and counter hypersonic threats. The first part of this new system is an advanced radar called CID, which uses multi-band phased array technology. This radar functions like magical eyes that can track extremely fast and small targets with remarkable accuracy. The technology behind this radar uses special materials called gallium nitride to boost its performance even further. Starting in 2024 and continuing through 2030, Japan is working on developing and testing advanced magic eyes for its ships. These high-tech sensors are part of a bigger system known as the Combat Management System, CMS, which acts like the ship's brain. The CMS is smart software that controls all the ship's advanced sensors and weapons. It's designed to be flexible and intelligent so it can handle all kinds of tough situations. To make sure it stays adaptable, they're using a method called open architecture, which makes it easier to add new features in the future. They're also using artificial intelligence to help the crew make quick decisions and manage the ship's systems more effectively. By 2030, Japan hopes to combine these technologies to create a powerful new defense system that can protect its territory from extremely fast threats. This advanced system will be a key part of Japan's defense strategy, showcasing its technological skills and creativity. In addition to this, Japan has recently introduced a new surface-to-air missile, but they're not stopping there. They're also improving their missile capabilities with a new system called the Ship-to-Missile Capability Enhancement. NSAMC. This missile is designed to intercept and destroy fast-moving hypersonic vehicles. The NSAMC missile features an improved guidance system called the Seeker. This advanced device uses infrared and radar sensors to detect and track high-speed targets like a superhero's eyes locking onto a target. It guides the missile precisely to intercept its target, making it a powerful new addition to Japan's defense arsenal. Japan is working on making its missiles even better by adding small rockets called side thrusters. These thrusters will help the missile be incredibly agile at high altitudes, allowing it to quickly change direction and follow fast-moving targets. The missile's guidance system, known as the Fire Control System, FCS, is also getting a big upgrade. This advanced software will manage complex situations involving various threats and will use radar information and data from a central control system to launch the missile at the perfect time and angle. It will also coordinate with other missiles and weapons. Japan plans to develop and test this advanced missile from 2024 to 2031. This is just one example of the impressive new weapons Japan is creating to prepare for future challenges over the next 10 to 20 years. It's like they're assembling a team of high-tech superheroes to protect their territory. What are your thoughts on the weapon created by Japan that's so powerful and has become terrifying? Share your thoughts with us in the comments section.